Today we're going to take a look at how we can rewrite a quadratic that's in standard form into vertex form by completing the square. And I'm going to do this by modeling it with algebra tiles. But before we get right into using the algebra tiles to do this with our quadratic, a couple of things we want to talk to our students about. One of them is the associative property. With the associative property, we know that we can group any two numbers or any set of numbers, and no matter how we group them, when we add them all together, we're going to get the same number. So we can start off showing our students that if I group 12 plus 5, I get 17, plus my 7 gives me 24. Well, I can do the same thing. If I group 5 and 7, I get 12 plus 12 is 24. So it doesn't matter what order or how I group things when I am adding. I'm still going to get the same number. That's my associative property. The other thing we want to talk to students about is keeping in mind that if I have any numbers, and I'm just going to go ahead and start with my 12 and my 5. All right, when I add these together, I get 17. Well, what if I add another number on? Let's say 6. Well, if I now add a 6 on here, that gives me 23. So these are not the same number. But if I add 6 and I subtract 6, now when I look at this, my original number, which was the 12 plus 5, gave me 17. That's the same as this number. So if I add a number and subtract the same number, then I end up with my original number. So that's an important concept for students to understand. Sometimes they don't see that when they're working with variables. So it's good to start off with just numbers so that they can see that I can add and subtract things, and no matter what I do, as long as I undo it, then I come back to having my original number. The same with work. If I have a binomial, if I have x plus 5, well, I can still add 6 and subtract 6. These give me 0, so I still end up with x plus 5 because these are going to cancel out. So it doesn't matter what I'm doing to this part as long as I'm working in pairs, a positive and a negative of the same value. So let's get down to taking a look at how we can model the completing the square using our algebra tiles. I'm going to start off just by representing my trinomial. In this case, I have an x squared, I have 6 x's, and I have a negative 1. So this is representative of my trinomial. When I complete the square, we literally want to turn these tiles into squares. So I'm going to line them up over here on my chart. So I know my x squared is going to go in the corner. Makes sense. Now when I look at this, I can say, well, I can take half of these. So I'm going to take these 3 and I'm going to place them vertically. And then I'm going to take these 3 and place them horizontally. Now, if I look at this, I'm still keeping in the line of a square. I have x and then 3 here, and then I have an x and 3 here. So it's the same length and width. Well, now I've got this little 1. When I put him here, this doesn't make my square. So what I have to do is I have to manipulate my equation. So I'm going to keep my little negative 1 over here to remind me I have him. Well, I need to fill this in. So I am going to take 4, 6. I'm going to take 9 of these little individual units, and I'm going to fill this in. Okay, so now this is a square. I have an x and 3, an x and 3, and all of these are done. I've filled it in so it makes a nice square. Now, I can't just add numbers. We already talked about that when we were looking at just the numbers. If I add 9 here, I have to subtract 9 somewhere else. So now I'm going to take off 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I'm going to take these 9 counters and I'm going to subtract them over here. Okay, I added 9, so I have to subtract 9. So now what I need to do is interpret what my picture says. I've made my square, so I have completed the square, and I've added and subtracted all of the numbers that I need to. So let's take a look at what this represents. This is x across, and then 3, so that's my plus 3. This is x, and this is again plus 3. Okay, now what I have out here is I have negative 10. So when I rewrite this, I need to take into account all of these. So I have an x plus 3, I have an x plus 3, and I have a minus 10. Completing the square also means I want to end up with a binomial squared, and I still have my minus 10. These are not part of the multiplication, so make sure students don't put parentheses around there and say it's times negative 10. All of this is being multiplied, and once I've done that, then I subtract 10 off the end. So that's how we represent this. If I want to, I can go back and double check when I go back and do the multiplication. I can go back up here and I say x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. And then subtract 10. So now I have x squared. 3 and 3 is 6. Plus 9 minus 10 is minus 1. So this is my original value. So now this is how I've done the completing the square as far as the algebra part. If I look at my algebra tiles, I can still see that this represents x squared plus 6x minus 1. When we're working with algebra tiles, a positive 1 and a negative 1 give me a 0 pair. So I can take those off. Every time I have a positive 1 and a negative 1, that gives me 0. Those are called 0 pairs, so I can just pull them off. So I'm going to go ahead and pull all of these off, one at a time. And what I'm left with is my x squared, my 6x's, and my minus 1. So these tiles, again, represent what I've done here. When we think about what we are doing algebraically, remember when I talked about the associative property? I want to manipulate this part so that it becomes a perfect square. That's why we talked to the students about saying it's x squared plus 6x. And then remember in our model we said, well, when I had 6x's, in order to make the square, I took half here and half here. That's where the half of this number comes in, is because we're dividing that in half to put in each side of my square. So half of that number, okay, and then we ended up with the 3 by 3 squared. Well, because we are adding the 9, I have to subtract it back off. And that's how when we factor, we get the x plus 3 in here and the negative 10 out here. It's still working with the associative property because I'm going to rearrange just these two, and then I'll do work on the outside. So those are some things that you can consider when you are working with your students who are trying to understand what it means to really complete the square, is that we are literally making a square out of our algebra tiles. Eventually they'll see, okay, I get half and half, and then, well, 3 times 3 gives me that. That's the 9 that goes here. And then when I look at my factors, it's back to whatever this half is. And I've got 2 of those because they're going in each direction. This concrete model helps them to develop that understanding conceptually in order to be able to move to this abstract model.